AI agents can write functional Python and debug complex logic, but struggle when deploying the rigid, rule-based configurations of an enterprise cloud environment. Consider an engineer asking a standard coding assistant to provision a Google Kubernetes engine cluster without providing any external context. The agent often generates code that is syntactically correct but structurally flawed, leading to violations of the well-architected framework. These hallucinated architectures frequently leave network gateways exposed or ignore specific identity and access management roles required for secure deployment. Large language models operate on probability and pattern matching, whereas cloud security requires absolute zero-tolerance adherence to logic. This mismatch means that out-of-the-box AI agents cannot be trusted to handle raw infrastructure deployment autonomously. Without a way to enforce deterministic rules, an AI agent acts more as a security liability than a productivity tool for cloud architects. To bridge this gap, developers rely on labor-intensive workarounds to force context into their AI tools. Engineers are forced to build custom Model Context Protocol, or MCP, servers to translate between AI prompts and cloud APIs. To teach an agent to interact with fundamental services like BigQuery, teams must construct this entire middleware layer. Every time a cloud service updates, the custom prompt definitions break, requiring a manual rebuild. The Google Skills repository is designed to bypass this custom middleware layer entirely. This repository provides a method for injecting operational context directly into the agent's native environment using standardized Markdown. Eliminating the need for custom-built bridges is a critical step toward creating a reliable environment for AI-led software engineering. Integration for AWS and Azure currently relies on a fragmented ecosystem of community-authored MCP plugins. Google is centralizing this process by supplying native agent skills to the developer ecosystem. This replaces complex API bridges with lightweight Markdown files that slot directly into the agent platform, providing clear instructions. In practice, a developer can now use simple package manager commands to pull specific, pre-validated skills into their environment. Defining infrastructure constraints through native Markdown ensures higher architectural fidelity than relying on the AI to interpret complex middleware prompts. This approach shifts the burden of defining best practices from the individual developer back to the cloud provider. Vendor-supplied operational context offers a level of standardization and scale that community-built workarounds struggle to match. The repository is organized into 3 distinct tiers that define how the agent interacts with Google Cloud. The Basics tier provides native support for primary services, including Cloud Run, Cloud SQL, and AlloyDB. These files provide the agent with the exact configuration syntax needed, removing the need for the AI to guess at foundational parameters. Beyond individual services, the Recipes tier provides multi-step workflows for common architectural tasks. This includes a recipe for onboarding to Google Cloud, which sets a secure baseline for any new project the AI initiates. The authentication recipe is particularly notable as it enforces secure credential management, a frequent point of failure for AI agents. There is also a recipe for network observability, allowing the agent to monitor the health of the infrastructure it has provisioned. By combining these basics and recipes, the AI is equipped with a set of authoritative playbooks rather than just a code editor. The most significant innovation in this repository is the hard-coded integration of the Google Cloud well-architected framework. Core principles of security and reliability lock directly into the AI's logic. If it attempts to design a single point of failure, reliability forces the architecture to expand into a multi-region configuration. Cost optimization then ensures resources fit within efficiency zones, preventing runaway spend. The agent now checks its own proposals against official Google parameters before any code is actually executed. The repository also includes a hidden gem, the Gemini API integration skill. This skill teaches the agent how to build Gemini's own AI capabilities back into the application it is currently developing. The market response has been immediate. This graph shows the repository spiking to over 5,000 stars, despite having only 28 initial commits. Reaching this level of engagement with such a small commit history suggests a high demand among developers for pre-validated, standardized cloud definitions. This rapid adoption indicates a massive industry-wide push to replace unguided, hallucinated AI prompting with reliable, structured, provider-backed knowledge. While promising, the repository is explicitly labeled under active development, and it currently has clear limits. Service coverage is not yet universal. Advanced features within specialized platforms like Vertex AI are not yet fully represented. Sophisticated database systems such as Cloud Spanner also lack comprehensive skills in the current version of the repo. Additionally, the repository currently requires users to operate within specific ecosystems, such as the skills.sh platform, to function correctly. These constraints highlight that we are seeing the first iteration of a new framework rather than a finished product. This shift represents a move toward a more fluid version of infrastructure as code. The rigid blocks transition into a stream of light. We are moving past the era where engineers spent their days manually drafting static YAML and Terraform files. Instead, we are entering a phase where vendor-backed operational playbooks are part of the cognitive layer of our development tools. For those working in GCP, relying on unverified community plugins for AI integration is becoming less viable. This framework allows engineers to build AI-driven systems that are secure, efficient, and well-architected by design.